In this experiment using Maya, a sphere is first of all introduced into the scene, and then half the sphere is selected and a translation is carried out which moves the top half of the sphere away from the bottom half. Then the original parameters for the sphere are changed to make the sphere high resolution, and as we can see, the model breaks down immediately in this particular application. The next piece of software is Softimage. The same operations are carried out on the sphere. Softimage advertises itself as being nonlinear, so you can actually go back to the original base objects and alter their parameters. But as we're going to see, just as in the last case, when we do go back to alter those parameters, we do see that the model breaks down in a pretty similar way to the one that we had before. We are about to see the node graph in Softimage. This allows the user to select any of the nodes that are in the graph, for example the sphere node, and they can go back and change any of the parameters that were used to create that object. Again, the object has been destroyed whilst changing one of these parameters. This next application is 3D Studio Max. Exactly the same operations are being carried out on the original base sphere, and once the object has been made, the user will go back and try to alter the resolution of the triangulation of the original sphere, and as we will see, the object will again break down. Max is able to inform the user at this point that this particular operation, or any operations on this object, may destroy the final model, as we can see with the dialog box that just appeared. This is now showing the same operations being carried out within our modelling software. This time, when the selection is made and the translation is done, the user is able to change any of the parameters of the underlying sphere model without breaking the object, as we can see in this case. This next example shows a complex, highly detailed model being loaded into the modelling software. We can see that this Harley-Davidson took about a second to recreate the model from the procedural description of the model. This machine is quite slow, it's just a 1.4 GHz with a GeForce 3, and we can still see that real-time interaction is possible with the object. The next object is in fact a simpler procedural object, but it does take longer to load in because it's got quite a costly call to a procedural noise generator. By storing these object recipes, we are able to go back to any node in the graph and select that node and change any of the parameters associated with it. In this particular case, we're going back to the very first sphere that was used at the very start of creating this plane, and we are changing the resolution or the tessellation of the sphere to make it higher or lower. This results in a higher or lower resolution plane. Although this system manages these changes better than its counterparts, there are still some times when a selection will become invalid, as we just saw with part of the tail of the plane. But as we have seen, it provides much better non-linear editing than the most used software tools at a fraction of the storage space, as we demonstrate in the paper, which is due entirely to the use of the procedural approach.